evening, everyone. Thanks for being here.
Good evening.
I was hoping we'd have some more people, but what can you do? They'll all be complaining next week. And I hope that those of you who are here will help me educate them since they're not taking this opportunity tonight. I'm Village Tivoli Mayor Joel Griffith. If you've never been here, the bathrooms are all the way down on the first floor. Trustee Bill Schilling is here, and Trustee Emily Mangieri is somewhere. There she is. The Deputy Mayor's out of town, and Trustee Baldino is under the weather. So tonight's purpose is to tell all of us who use the Tivoli sewer system the state of our sewer system, the effort to replace it with a new sewer plant, how much that's going to cost, where we think we're going to find money. Find money, yes. Couch cushions, right? And we're going to have a big, lots of time for Q&A is built into this, so as we get into our presentation, there's a lot of information. There's going to be some history, some technical stuff. We can all geek out on the different ways to treat sewage. So you understand what we're going to be paying for. Then we'll have Q&A at the end, so please do try and hold your questions. I'm hoping for those of you who were around when we did filled this room and talked about should we transfer to the Water Authority, where should we put our new water tower, what should it look like? I mean, we've done this before, we've come together in this room as a community, looked at the decisions we have to make, and hopefully make the best one that most people can get behind. So this is the sewer analogy to what we did on the water a couple years later. Tonight, we're very fortunate to have with us representatives from the Dutchess County Water and Wastewater Authority. That's Jonathan Jurens and Gary Banks. There's Gary, okay. And also here from Wright Pierce, which is the engineering firm who's designing the new plant, is Kevin Hickey, and they will be doing most of the talking tonight. Many of you know what we've been up to for the last 7 going on 8 years in the village of Tivoli when it comes to water and sewer. But if you don't, or you forgot those difficult decisions, I'm just going to kind of give you a quick timeline of what we've done since 2015. When the village applied for and won a county grant to do a feasibility study of transferring the water and sewer to the Dutchess County Water and Wastewater Authority. 2 years later, in 2017, that resulted in these giant reports. This was when we hired Ty & Bond, an engineering firm who also worked on the water tower, to look at every part of the water system and the sewer system, find out its current condition, divide the to-dos into, should have happened yesterday, immediate, short-term, long-term, and 2017 costs. And I don't know anything that costs the same now that it did in 2017. Incidentally, these are always available in the clerk's office if you want to come in and read through them. So we got that news, and in 2018, we were fortunate enough that we went to the EFC, which is the New York State funding agency, the Environmental Facilities Corporation. Correct. And we said, here's our water project, here's our sewer project, and they will fund up to 60% of your water in a grant and 25% of your sewer in a grant. And we were lucky, we got 60% of the water, 25% of the sewer, 2018, based on that project cost. So we ended up with $2.8 million grant towards the water out of a $4 million and change project. And we got just under $1 million, $919,000 towards the sewer project, which back then was going to be something around a little under $4 million. In spring of 2019, the Dutchess County Legislature created a water and sewer district around the water and sewer users here in the village. So a village can have water and sewer, we have the authority under state law. In order for the Water Authority to come in here and be authoritative, a district had to get made. So the county legislature took that action and created something called Zone 10. So we all got our town tax bill recently, and you'll see down there, Tivoli Zone 10, water. So that's an assessment. We'll talk about that tonight as well. In 2019, the Village of Tivoli and the DCWWA entered into an agreement whereby the DCWWA took over operation and management of the systems, including billing, daily operations, capital planning, and capital improvement oversight. And then we had March 2020 and the pandemic. And that did have major impacts on our multi-year effort to get going here. One thing that happened was the state, who had set up that financing package for us, said, ooh, you know what? We don't know what's going to happen, so we're just going to freeze that funding till we kind of get a sense of what this pandemic's going to do. And that caused us to lose a lot of time because we needed to design a sewer plant, and you need to be able to pay engineers to do that. So that probably knocked, I don't know, a year about out of our efforts. And we tried very hard to get them to let that money go, but like they didn't. But eventually we got that money in and we got going. The other thing it delayed was the erection of the water tower. That happened about 8 months or 10 months later than it should have, also due to the pandemic. Around the same time, in January 2020, we started getting calls from the EPA, Environmental Protection Agency, and the DEC, who you know, that we were having violations and exceedances at our sewer plant. And you know, we have something called a SPEEDIES permit. SPEEDIES stands for?
State Pollution Elimination Discharge.
Very good, thank you. I'm never going to get that one. So this is about, you know, what's the quality of your treated sewage when it goes into the Stony Creek and into the North Bay and into the Hudson River. And obviously, it has to be right. And our plant was starting to not meet its SPEEDIES permit. And as these regulatory agencies were starting to pay attention to us, we said, we know, we're trying to fix this thing. Why don't you go talk to your people down the hall who are freezing our financing? So anyway, things are, I'm like, don't fine us, give us every penny that you would fine us so we can put it into the new sewer plant. And we were able to kind of make that argument. So we're going to get into something that Tivoli is under right now called an order on consent. And Jonathan will tell you more about that shortly, but the state is telling us, you've got to fix this sewer plant. And in the fall of 2020, we did get our new water tower up. In the summer of 21, the old one came down. The water mains from most of Woods Road, all through the village, up to the new tower got done. So we kept doing our thing despite the pandemic as best we could. The wells are being worked on right now. So our water wells, there's all sorts of new technology going in there so they can tell each other how much to pump to keep the tower going. It's all remote. It's not Jimmy going out every morning and turning them on, turning them off. But thanks for doing that, Jimmy. Appreciate it. So when you come in on Broadway, you'll see at the McKnight well field under the water tower, you'll see there's sort of a tent over the well house because they're working in the well house right now. And that pretty much brings us up to now. This fall, Wright Pierce and the Water Authority have been designing our new sewer plant. We are at what's called 60% completion. And they can talk more about the phasing of, I'm going to build a sewer plant. What are the phases? What's appropriate? But at 60%, they pretty much know what it's going to look like. They know what kind of technology they're going to use. And we can start getting some much more accurate cost estimates. So that is coming as well. So again, thank you very much for being here. This is like we did with the water system. This is about transparency. We on the board pay the same bills that you guys do. And we as a community are going to have to face this challenge together. So thank you for being here. It's very important. And let's learn about where we are. So Jonathan, thank you.
Great. Next slide. I'm going to come out here. So again, my name is Jonathan Cherns. I'm the Deputy Director and Senior Project Facilitator for the Dutchess County Water and Wastewater Authority. And I'm here to tell you a bit about our organization, walk you through some portions of the project, and I'll be teaming with Kevin to talk to you about different parts here. Our agenda is up here on the board. I'll give a little bit more of a dissertation on what the Dutchess County Water and Wastewater Authority is. I'll give a little bit of project background. We will work through the existing conditions of the facility. There's photos and drawings and maps around the room that you can look at as you exit, and we'll happily talk to you after the presentation about those. We will review the proposed wastewater treatment technology, the treatment plant upgrades. We're going to review the proposed capital cost estimate as it stands today. We'll review the funding sources. We'll touch on the anticipated project schedule as we see it at this moment. We'll do a summary and conclusion, and then we'll look to answer questions that you have. Next slide. So the Dutchess County Water and Wastewater Authority is a public benefit corporation that was created by the state at the request of the county. We started working in about 1992. We own and operate about 30 systems across the county, both water and sewer, and we do end-to-end integration. We work very closely with the county. We have a board of directors that are appointed by the county exec and legislature. So we are tied to county government, and we're very responsive to our local communities and partners, and tend to work with any advisory groups that may come along over time to speak to the water and sewer in a particular area. Our mission is solely water and sewer. We look to make sure that we're treating the materials appropriately, providing clean water, and discharging to the environment in an appropriate manner while being as cost conscious as possible, with accountability and transparency. The Water Authority, as Joel had mentioned, has been operating your water and your sewer systems since 2019 through an agreement with the intent to eventually transfer the system to the Water Authority. Major systems that we own and operate throughout the county would be the Hyde Park Regional Water System that we acquired in 1999. We've resolved many community issues across the county by interconnecting systems, by coming in and understanding the liabilities similar to what we have here in the Tivoli sewer system, working with our engineering partners to then come up with a new design and then implement that. Through that process, we try to seek outside funding to buy down the cost of the project and find the best value. Next slide. So there are actually two phases to the project that's before us with the sewer system at this point. There's a collection system that encompasses about 4.75 miles of pipe. It's an older clay pipe. Some of it was installed back in the 1938 timeframe. It's 8-inch, 10-inch clay pipe, small pieces of pipe, many potential for water to come in from the ground or from the surface. And so that's important because the wastewater treatment plant through the collection system is receiving a considerable amount of water from the ground and the surface. And over time, we're seeing that increase. There are other reasons why the water would come in, and we're looking to, in this phase, do an evaluation, a design, and then implement an improvement. I will come back another day and speak to you about this particular component. It's not necessarily what we're here to talk about tonight. Happy to answer questions about it at the end, but I want to stay focused on the wastewater treatment plant. And I will also say that the cost of the collection system improvements that we're proposing at this time are included in the numbers that we'll show you. The second phase of the improvement that we're here to talk about tonight is your wastewater treatment plant. It is a facility that was built in the 1930s, improved in the 1950s. It had another improvement cycle in the 1990s. It is aging out. All the components of that facility are reaching mechanical, electrical, automation are all coming to the point where they have systemic failure. The structural integrity of the tanks is such that it's starting to fail. There is quite a bit, if you walk around and look at the photos, you'll see there's a lot of rust, broken components. It's all based on age. And so you have gotten the value out of this facility, and it is time to do the next step. Next slide. So collection systems are my favorite thing, so I will talk a little bit about this just before I go. I've sort of hit on a few of these items. With this clay pipe, and it's throughout, and it allows the groundwater in, the stormwater comes in, and you need to address that. And so there are certain technologies that we can implement after we've done an evaluation to line that pipe more efficiently and more cost effectively than coming through and doing a design where we have to dig and then put new pipe in and then restore back in the end. So our goal would be to use that technology, which we've used on other systems. I actually just completed a project in the Greenfield sewer system down in the town of Hyde Park, where we've seen significant improvement with the amount of water coming into the system that we don't need in there and want to keep in your stormwater system. Essentially, at this moment, your wastewater treatment plant is designed to treat about 100,000 gallons per day, but we are seeing storm events where we're seeing the water come in and we're approaching 500,000, sometimes 1,000,000 gallons. So 10 times the amount of flow, and that is significant and impacting the wastewater treatment plant. The improvements that we would do to the collection system are a good savings when it comes to having to do improvements elsewhere. And a better way to get rid of your stormwater or your groundwater is through your stormwater system, which is the least expensive way. So again, I'm going to come back another day and we'll get into the details of your collection system. And over the next year and into next year, we'll be doing work in that area. And I'll be communicating to the community through press releases, to our website. I'll come to the community when you want to hear from me, and I'll speak to certain components. We can go into deeper detail about all of this. But again, collection system, now we're here to talk about the wastewater treatment plant. So we go to the next slide. I'm actually going to hand off to Kevin for a few minutes, and then we're going to team back and forth. Kevin?
Thank you. Good evening, everybody. Kevin Hickey, I'm with Wright Pierce Engineers. I'm Senior Project Manager for this project here. And so I'm going to talk about a lot of technical stuff. I know Joel mentioned save your questions. If you don't understand something that I'm talking about technically, feel free to jump in and ask, because there may be a different way I can explain it to you that makes more sense. So please feel free to interrupt me at any time. So this is your current wastewater treatment facility. There's a number of pictures around here that kind of give more depth than this, but this is kind of an overall picture here. I'm probably going to jump in front of the screen and kind of point some things out so you understand it. So in general, your collection system, like Jonathan says, collects all your wastewater, your shower, your flush toilet, goes down the drain. It enters the treatment plant up here, number 2, influent screening. So what influent screens are, essentially pulling out rags, 2x4s that do come down the sewer, all sorts of crazy stuff. And so the screens are essentially metal grates that capture any real big stuff. So that impacts the treatment plant significantly. If that gets through, if pumps break, treatment doesn't happen, right? So all that stuff gets pulled out in the influent screening section of the plant. You also have an equalization tank, and what that is, Jonathan talked about normal average daily flow, 100,000 gallons a day, you can see a million, right? And so this tank down here, number 1, is supposed to offset if you have big peak flows. Now, that tank is only 46,000, so when you see these huge flows of potentially a million, obviously 46,000 gallons doesn't do a whole lot. So that's why this fixing of the collection system is so important for the wastewater plant. So that's flow equalization, and that's a little downstream after the screens. After the screening portion of it, we also want to remove grit, so that's sand, that's smaller pebbles, things of that nature. Also can impact the treatment system, can wreck pumps, things of that nature. Don't really need to treat sand either, it's not biological. So that is, it's hard to see on this, there's better pictures over there, but they're channels that are about yay wide and maybe 5 or 6 feet long, and anything really heavy settles out. So sand is heavy, it settles out, rocks settles out. After that, we start the biological treatment process, or the removal of it's called BOD, it's biochemical oxygen demand, essentially organic matter that goes down, food, human waste, whatever it is, biological or organic matter, and total suspended solids. So that can be biological matter of some sort, but it could also be something that floats in the water, food, etc. And so through primary clarification, so number 4 here, we try to settle all of that out. And so it's very slow moving through this, and we try to settle out that stuff that didn't settle out maybe in the grit, and settles out better, slower, and so that's happening in the primary clarification. So the goal there is to remove anywhere between 30 and maybe 40% of your organics through that process. Those are then pumped actually to a sludge tank, the stuff on the bottom, which is located down here, number 10. So after primary clarification, which is really a physical process of, again, settling, we go to really a biological treatment process, and that's for your plant, rotating biological contactors, and that's number 5 here. They're kind of semicircle actually, and you can see them as you walk around. And so this is where we actually use microorganisms to break down organic matter. So it actually eats it, degrades it, uses it as fuel. And the way that's done with these types of treatments is there's a wheel, essentially, multiple wheels that are kind of lined up here with a gearbox, and it spins this, right? And so it spins it, and the bottom half is actually water, and then it goes in and out of water. So microorganisms need oxygen, they need food, the same things we do, right? And so they grow as a film on these wheels that are in along this shaft here, and they break down essentially the organic matter. After that process, we need to remove more organic material again. That's by secondary clarification, so same as primary. So again, you're settling stuff out that wasn't removed through the rotating biological contactors. Also, that film that's around those wheels can slough off as it gets bigger. You can think of it as like something that grows in your bathtub or something. It's a film of biological, it can slough off, comes off, has to be settled out. So that's what we're doing in the secondary clarification process. Joel mentioned your speedies permit. It has limits on the BOD and TSS that I mentioned before. And so to make sure we're meeting those, there's tertiary sand filters. So that's removing, it's like a pool filter if you have a pool. It's sand, it passes through it, it's removing even more of the material. So we're meeting that requirement for the biological matter, and also even some of the inorganics that are in there. So that's a sand filter. So before it discharges to Stony Creek, the DEC requires that, as part of wastewater, we know that there's microorganisms in it, both good and bad, right? So we need to disinfect the wastewater. So we get rid of viruses, we get rid of any bacterial harmful things that could affect the flora and fauna in the creek, right? Or in the stream that eventually gets us to the Hudson. So we want to get rid of those bad viruses. We use it to fish, we use it to swim, etc. So that's disinfection, the way that's done right now, currently, and we'll talk about the change that we're going to. But right now it's chlorine. It's been used for hundreds and hundreds of years. It's a good disinfectant, so that's currently what's used right now. There's also a requirement to remove chlorine technically before you discharge, so there's another process there for that, but for disinfection purposes, we use chlorine here. And then the last, before we get into the kind of the solid side of it, is the post-aeration tank. And so, again, going back to the fish, going back to the organisms, the plants, we need oxygen in Stony Creek, or else those things can't live. And so, going through this plant, we deplete oxygen big time in it. So we're discharging potentially a lot of liquid that has no oxygen in it, which means you're going to kill some organisms. So we have this post-aeration tank, which essentially adds oxygen back into the water so that it doesn't kill things once it's in the stream. So then after that, it gets discharged. You can't see it here. There's another photo later in this presentation, kind of the outfall. That actually goes into Stony Creek, just a pipe that kind of sticks up, overflows. And then, so that's kind of the treatment side of it. Then there's the solid side of it. So we talked about the sludge off the primaries. There's the sludge off secondary clarifiers, and that gets held in the sludge tank here. That's still kind of very liquid. It's probably only 2 to 3% solids, so it's like muddy water kind of. And so we don't want to get rid of a whole bunch of water. It's not cost effective to do that, so we want to de-water it. And so after it goes from the sludge holding tank, it goes to these reed beds. So these are pretty big. Essentially what they do is the reeds grow up, they use water obviously to grow, they're de-watering it, so then at the end you can take solids off and you can landfill them. They're not 2% solids, they're 30, 40, 50% solids. So you're getting rid of more dirt kind of ish. So it's cheaper than hauling a whole lot of water. So that's your existing system. As Jonathan said, it's reached about 30 years, so it's generally the age of a treatment plant, 25-ish years. So gotten very good use out of it. It's done what it's needed to do. It's just kind of getting towards the point where it needs to be upgraded and replaced. So I guess before I turn it back over, any kind of questions on the existing system, what it does, how it does it? Yeah, go ahead.
Where do you take, you said with the sludge last part of it, that is hauled away?
Correct.
And where does it go? And what is it like?
Typically landfill, so it's kind of like
Goes to a landfill?
Yep, so you pick it up, it's kind of like dirt. more wet dirt, if you will, is kind of the consistency of it, but it's hauled usually typically to landfills. Now, we can get into a whole dissertation on the sludge side of it. You guys don't do a whole lot of it here. Connecticut, for instance, they burn all of their sludge. They incinerate it. New York doesn't allow it. I think there's 2 left in the state. So it's very different, even though the EPA is the overarching, state by state goes very, very differently on how that's done. So, but here in New York, primarily landfill application. Yep.
You just said that it was 25 years old? Did
Well,
I hear you right?
that the normal life of a treatment plant, if you will, from when it's first constructed until when it probably needs to be replaced is about 25 years.
But ours has been there since the 30s.
But it's been updated since. So
Oh,
yes, it
okay.
was originally done in the 30s, it was updated again in the 50s, it was
Yeah.
updated again in the 90s-ish. So
But updated is different than what you were going to do. I mean, I don't know what the extent of the updating was.
most of this tank, these tanks, this is all in the 90s. So
Okay.
this old tank, this isn't used anymore. We'll
Okay.
talk about that later actually, because we're gonna reuse it. That's from the way
Okay.
back. Some of the screen might be from the.
So it's about 25. You're saying. it's
You're at
25.
30, almost 35. So
Okay.
it's done in 90-ish, you're
Okay,
32, 33 years.
thanks for clarifying.
Yep, no problem. Anything else before I get to Jonathan here?
Let's keep this slide for a second.
Great.
So I just want to go through, and you can afterwards walk through the photos here, we'll gladly talk about them as, after the meeting. But just looking at this list here of different components, I'm going to give you a little bit of scope as to the condition of the current facility. The flow equalization, that's that long tank here. About 10 to 15 years ago, my understanding is that it floated out. And it is a steel tank. It is hold through in certain spots. Its structural integrity is questionable. If we do any digging around it, it will probably collapse. The influence screening, it has, the tank is in relatively good condition, but it's undersized for the current facility. The screen has been replaced multiple times, and typically we take grading from somewhere else from an old facility where there's some leftover and we reuse that. A little adaptive reuse. The grit removal system, which is these little bars here that you can just barely see, they are undersized for the flows that we typically receive, especially with the amount of flow from the collection system that we receive. So the grit ends up running into the other components. It overflows when we get a major storm event. Primary clarification is a tank that has structural issues. Oh, and the grit chamber also has structural issues. It's rusted through. The blowers that are on the primary clarifiers are broken. There are no spare parts. There's still one operating. The RVCs, or rotating biological contactors, these are the 2 white things here. They are, they've had multiple repairs through time. There's a long shaft in there and the ends have been cut off and then reattached. The one motor's been replaced. The media is held together with steel structured membranes. Members, and those on one of the RVCs is starting to fail, and so we get media slop. So you stand next to the machine, it normally should just be this nice hum, but we get and then slop, and then it comes around again, it slows down, and then it slops, and that leads to early failure, and we would need a whole new RVC there. The bearings are also showing their age again. Everything here is age-related. Secondary clarifier, very similar to the primary clarifier. It is structurally has issues with the steel. We're beyond the typical lifespan for a steel tank. There's no way to really repair that. We've done it with other facilities where we've taken plywood with silicone and carriage bolts and kind of held it together for an extra couple of years while we get through a design and then an implementation. The blowers that are on the secondary clarifiers are broken. There's one still operating. There are no spare parts. Redundancy is gone. When we get to our tertiary sand filter, it's supposed to be an automated system, so you can keep it in a very small package. The automation has failed, and so we have to operate it by hand. And it is, the media is original, and as the media is kind of basically sand, and it's supposed to have little rough edges to it that makes it do its job, so that it keeps things from going through it, and you can take off the slough off the sludge off the top. The sand filter quickly clogs, and because we have to manually operate it, it doesn't get to call for when it needs to be managed, so the operator has to be on site more often. Disinfection, the facility was set up with gas chlorine at one point, failed, has been We've removed all those materials that were on site. There was a UV system installed at one point that is aging out and has failed. We're now using liquid chlorine, which is an appropriate technology, but the discharge permit that we'll talk about a little bit more in a bit requires the chlorine to be removed so that we don't send that out in the environment, because chlorine is not good for fish. The post-aeration tank, the blowers have failed, and we've, through an adaptive use of other pumps, have created a way to keep the dissolved oxygen out so that, again, we don't harm the fish. We have sludge holding tanks. The blowers have failed. You're seeing a pattern here, I hope. And so we do have one blower working because we were able to pull some spare parts from elsewhere, but again, it's on the edge. The steel tank is not in good condition. The reed beds are a good use of space to dispose of your solids and really thicken it up and make it so that you don't have as many trips to get rid of it. But at some point you have to deal with it. And so there's probably 30 years worth of sludge that's been drying there, and now we need to build a plant where that is located. And there's not a lot of space in this facility. I just wanted to give a quick understanding of this is the condition.
So 30 years of sludge buildup because they didn't remove the sludge?
Well, it's an interesting technology where you use the reeds to actually grow there, and they oxygenate the sludge, and you're able to dewater it. There's actually an under drain system, so the water will come out, and then we have a pump system to send it back to the system. You send it to headworks and treat that again. So it is a innovative way to reduce the sludge and also treat it. But at some point, the bill comes due, and we are there. So to say your facility is, you've gotten a lot of very good use out of it. It's a steel package plant, and it is now time to move on to a new solution. There is no solution here to say we do nothing. We have to do something. And we'll get into more into that.
I have a question. I'm
Sure.
new to this. I apologize.
Happy to.
What's the capacity again? How much water is it capable of doing? You said a few
100,000 gallons.
100,000. And you said that you were seeing of maybe 500,000?
Or a million.
Or a million.
So-
A day? Or are we saying?
Yeah,
Storm events.
clarify though, so the average day is designed for 100,000. Plants are a normal, so we design an average and we design a peak. And so peak is typically about 4 times. So typically plants can take upwards of say 400,000-ish. But 10 times, no, it's not. I wouldn't say that's normal from a design standpoint, but from the DEC dictates to us engineers that we have to use peaking numbers, right? So typically 4-ish. So when you hear 500,000, that sounds like a lot worse than 100, but it's typically,
typical for 400,000.
yeah-ish.
So my question is, so why are we seeing a million? I mean, you're saying the storm, I mean, again, technically.
Yeah, Kevin's not a part of that project, that's my fault. And I will definitely come back and we can go really deep into that.
Okay,
And
yeah,
there's
I mean-
gonna be a lot of work in the community, both understanding how we can address that
Yeah.
and working in the roads and
Mhm,
the rights of ways.
Basically, pipes. We need new
Is a
pipes.
good
That's-
component of that.
We all need new pipes.
Can you,
That's basically.
yeah, I couldn't hear that. Why is it about $1 million? You said, well, basically, this lady said.
Sure.
I said
I'm gonna
basically
give
leaky
just a
pipes.
little,
Leaky
yeah.
pipes, okay.
It's leaky pipes, the pipes get offset, there's
There's a
roots
fault.
intrusion, they're basically 1930s clay pipes, and over time, they're gonna
Yeah,
crack.
you're right, okay.
Yeah, and I'm gonna come back and talk about that another day, because we have a lot to get through with the wastewater treatment plant.
But there was a talk a while ago, years ago, about separating the storm drains from the regular sewer system, and what happened to that?
Sure, they should be separated, and
And they're
so,
not? I thought some of them were, or?
they should be, and I believe they are, but we can, there's, what we're talking about here is not necessarily the separation of the stormwater system, it's the stormwater is getting into the sewer. So water running over the surface, percolates into the soil, the pipes in the sewer system are cracked, it gets in. The manholes have holes in them,
Yes.
or they're not well fit, the water goes in.
Okay.
There are other ways that the water can get in also, and again, that's another night. I can go into a lot of detail there, and there's a lot of energy here about that, and I want to come back and talk about it, but we really got to get through the wastewater treatment plant. So, and maybe after we could have a quick conversation about it, I can give you a little more detail about that, but I don't want to steal from the wastewater treatment plant, because this is a big piece we're working on. So, yes, sir.
So it sounds like the only viable structure is that round thing you talked about.
We're going to talk a little bit about adaptive reuse of tanks in this facility, but just to highlight it, the post-aeration tank will be able to reuse, we believe, the Imhoff cone, which is a circly thing, the control building, and I believe that's it.
Oh, no.
Yeah, the rest is steel, and steel is not known for a long life. Concrete is a legacy, and you can use that over and over as long as you've maintained it. My last project, we were able to reuse just about every tank, except for the steel. And the steel tanks that are here, even if we could reuse them, they're often undersized. So there are better technologies and better ways for ranging all that. And Kevin will go into that in more detail. So if you'll bear with me a little bit longer, let's go to the next slide. Thank you all. Great. So we've talked quite a bit about the systemic failure of the modules. There is a state pollution discharge elimination system, the SPEEDY permit, that is put in place. This stems from the U.S. government putting together the Clean Water Act back in the 70s that then created a system where states could define how much pollution could be sent into the environment. And this lists all the different parameters that go to protecting the downstream users. In this case, you have the Tivoli Bays area, any users that are on the Hudson River, all the drinking water systems, and those that would recreate in both the stream as well as the Tivoli Bays and the river. And so this permit defines how we can discharge, and it goes into how much oxygen dependency that the water can have, how much solids or tinting can be in there. It goes into the pH. There's a whole set of different components that go into that. And the facility in its current condition, it is failing on several parameters. This would be the list here. There's CBOD failures, there's TSS, which is total suspended solids, average daily flow. We talk about the stormwater coming in and affecting the plant because we get so much in the average over for a month. Fecal coliform hits, phosphorus, temperature is over, and then dissolved oxygen. And so the facility in its current state, because of its aged condition, is not able to, in these storm events, and mostly on an average day, able to meet those permit requirements. From that perspective, we are regulated, the village, the operator of the system, which is the Dutchess County Water and Wastewater Authority, to maintain that discharge in compliance with that permit. The DEC, the Department of Environmental Conservation, as well as the EPA, the Environmental Protection Agency, have noted that we have had these exceedances of the permit, and therefore they have given us an order of consent. What does that mean? It's a legal document that basically defines that you must go out and understand, create a design, implement that design, and rectify your wastewater treatment plant so that it meets that permit. There are fines that go along with that if the village and the operator do not complete that component. And so we are duty bound to make this plant work however we can. Right now we're doing a lot of innovative efforts to try and make the plant operate. It's difficult to work with those flows. But the main component of that is we are doing this two-pronged approach of a collection system that needs to be addressed. I'll come back another day and talk about that. We have a design for the wastewater treatment plant that we're working on, and we're working to get that to the regulators so that they can review it and approve it. We've worked with our partners, both the federal and the state level, and we're continuing to do that to seek more funding so that we can make this more affordable and reach that point. So we are at a point where we need to perform and improve both the collection system and the wastewater treatment plant based on this order of consent. Next slide.
What's the time frame on that?
Back. June 1st, 2025, we're required to have reports to the DEC explaining how we're going to go forward. We are on the fastest schedule forward at the moment, and we do have a schedule later that we'll talk to. And so our goal is to be...
So that's just the report, that's not necessarily...
We're ahead of schedule. We're ahead of where they want us to be.
Okay.
Yeah.
Jonathan, could I jump in? So
Sure.
the village board has signed that order on consent. We are legally bound. We have been through a lot of hard negotiation by the village board and our excellent attorney. We have gotten those fines to be held in abeyance, and they will be held in abeyance as long as we get this thing done by the right date. If we don't, the fines come.
So just when you say get these things going, you mean actually start the work or the plan?
I mean, start meeting our permit. And the way to do that is with replacement of the sewer plant.
So
Yeah.
start with.
Yep.
No work. Next slide. Great, actually, I think this is you guys, so I'm gonna step back.
Alrighty. So we talked technically a little bit, we're gonna get even more technical, so please interrupt here. So we talked about the two projects. So we are doing a little bit in the collection system here. We are replacing this pump station that you have. And so that is also outdated and past its useful life. It does what it needed to do, but also needs to get replaced. So two parts of this are replacing the existing wastewater plant, we talked about, replacing this pump station, which is actually in town, and then the collection, separate project. The photo here I want to share with you is this is a project very similar size to the village of Tivoli that we recently completed in New Hampshire. It's the same technology that I'll talk about that we've selected for the proposed technology. That's those concrete tanks there. We also have a similar building that we've selected for this plant that's similar to this building here. It's a pre-engineered metal building, so it's not stick built or anything. It comes, and so this is a picture of something similar that will be at the site here. So it's a little hard to read here.
Impossible.
It's over there as well, so we can talk through this to some extent. It's a little different setup over there. Essentially, this is talking through the process that we talked about before, except a little bit in that what we're doing. So influent again, we have a flow meter here, essentially how much flow is coming into the plant. We have two screens, we only have one now, and the proposed there's two. One is automatic, so it potentially flows, we'll talk about it as we go. It's on a rotating screen and it pulls the solids out. Then there's a bypass, so if there's high flows, it goes through a separate one. We have a drip chamber again, except this is aerated. It's going to have essentially blowers putting air through it so that it separates some of that biological material up and the sand and dirt and gravel settles down. The treatment selection, instead of the RBCs or rotating biological contactors, are SBRs. Those are sequencing batch reactors. We'll talk about kind of what they do and how they're different here in a little bit. We have, after that, we also have tertiary filtration. So instead of a sand filter, it's a disc. And I'll show pictures of that. It's a little different, but does similar things. We have disinfection again. So in this case, it'll be UV. You mentioned that. We'll talk about have individual ones of each of this, so it'll be a little easier to see. Post aeration again, bringing that DO or dissolved oxygen level up, and then discharge to the stream. So this is a general process flow, similar that we talked about, but for the new facility. So we'll go on each component here. So this is the screening part of what I'm talking about. So this is the mechanical system. Essentially, it's a perforated basket, but it spins, and it pulls out the solids up this shaft and dumps it into the container. So right now, the operators are using a rake and scraping the stuff and putting it in a bucket. Right, this is a mechanical system, makes operation much, much easier. Better for the operator, better for my maintenance, pulls more solids out, the bigger stuff. So
Can handle the 2x4?
it can handle, a lot of these things cut those up, this one won't, but some of them do cut it up, so yes. Much better for that.
2x4s are rare.
They are rare. But here's just with the smaller pipes, yes, if you went down to like, or across the Kingston or whatever, they'll get 2x4s, they'll get all sorts of, I mean, it's pretty crazy the things they actually see. After the big screening stuff, we have the aerated grip chamber. Again, it's a similar chamber to what you guys have now, except it's aerated, so it's blowers. Again, you want to float the light stuff up, get that out, and settle the more sand, the gravel. And that will be removed manually, so there'll be two of these chambers. And so we can take one out of place. That's the other kind of issue that currently is had, is the existing system doesn't have a whole lot of redundancy or means to clean things out because it only has one method to do it. And so the grit, the dirt, the sand will be moved out or moved manually as it needs to be. So
How often does that have to happen? Why manual?
no, not as often as you think. Actually, probably every 6 months, every year. It's not something that has to be done. I mean,
It depends on the facility.
It does.
Right now, the way the facility operates, we're probably, I didn't see who it was, I'm trying to look at their person. It's a daily task, and Vanessa, one of our operators, will get out there with a shovel, and she kind of tamps it to get the floaty stuff to go, and then she tries to scoop up the sand. And it's an important part of understanding the system, but the way the flows work with the way it's currently arranged, it does blow itself out.
Yeah, and these tanks are all going to be cement as opposed to current?
correct. Everything that we're talking about here is going to be concrete, which is, I'll say, a more standard. So the facility, go ahead.
I was just wondering, are you designed to the same capacity or are you upgrading capacity?
So it's going to be, we looked at flows ranging, and so, I don't know if we actually have a slide on that. So the average daily will still be the same, it's about 100,000. So if you look over 365 days, that is still about the average. Actually, you operate a little less than that, somewhere in the 60, probably 80,000 gallons a day, it's typical. So when we look at flow over 3 years, the peak average, or peak flow rate that we look at is about 500,000 gallons a day. So when we're looking at this, that's the peak. Hydraulically, so you do get 1 million gallons. This plant will be able to pass 1 million gallons a day. The DEC requires you to treat a certain extent of all that. So the disc filters, or the tertiary filters that we're using, don't have to treat that peak. They bypass that. They get disinfected, so we get rid of viruses, bacteria, things of that nature. But DEC, when you have peaks, does not require you to do that secondary filtration. That's any plant, not just yours. Any plant in the state, you can bypass that at high flows. So, to your question, 100,000 gallons is the average, up to 500,000 for peak flow that it can treat through the whole system, right? And then after that, we bypass it.
For short periods.
For short periods, right. And again, that's any plant. You go up and down the Hudson River, they all do that. You go to Albany, they dump millions of gallons of untreated into the Hudson River. So, next slide. So this was the biggest evaluation that we did, and this is your treatment using a biological system. And so a lot of what we talked about is, settling out of solids. That's just, we're using gravity to settle stuff out. The bugs are what really get you down to meet your species per million. So these are a number of different options that we looked at for treatment. We look at cost. We look at long-term operation. We talk about ease of operation. This plant is not operated full-time, and so we want a system that can be operated so that somebody doesn't have to be there 24 hours a day. Obviously, that would cost even more from an operation standpoint, right? And so these are 5, I'll say, very standard treatment processes that are, if you look at across the country, that are used for wastewater treatment. Obviously, you guys have RBCs now. It's worked, it still works. Plants are still designed using RBCs. Membrane bioreactor, it's a slightly newer process. Essentially, again, uses microorganisms and then a membrane to remove the solids. So what's in here uses biological, again, microorganisms to degrade it and then through a membrane. Sequencing batch reactor, this is what we designed around. So what this does is, again, it's one tank. So we talked about primary clarification, we talked about secondary clarification, we talked about RBCs, RBCs, so that's what you have now. This does everything in one tank. And so the way it does that is it keeps this brown layer here, which is essentially the microorganisms, and it adds flow periodically and runs different cycles. So it does settling, it mixes it and does biological treatment, it stops the mixing, settles it again, and then we decant off the top and take clean water off the top and keep the stuff. We want the microorganisms to still degrade wastewater. So we keep that at the bottom, clean water goes off the top, we refill it again with wastewater as it comes in and go through continuous cycles. So that's a sequencing batch reactor.
I have a question.
Yes?
How many gallons is that sequence batch reactor?
The actual size of the tank?
Yeah, like
I don't remember how
how
much
much water would you say?
Oh, less than
20,000 gallons.
So there's 2 of them, and they're each 20,000 gallons.
Oh, okay.
So the typical time frame of each cycle through each of these reactors, I think, is 4 to 6 hours, is that right?
Something like that.
So you have this wastewater, like I said, that goes in, goes through the different phases over 4 to 6 hours, and then discharges. So there's 2 of them that were designed around, and so while you're in one phase, say you're settling in one, maybe you're filling in the other, so you're be able to balance the flows. And the benefit of these as well is there's 2 different actually methods of types of SBRs. There's one that really just sticks to the cycles, and then this one that we designed around is called a continuous flow SBR. So this front tank is actually always getting water in, and so it can handle up to 6 times your average daily flow, which is a huge benefit of this. It's reduced footprint because it does everything in one tank again, so you don't have primary clarification, RBCs, secondary. It's all compacted in one tank. So for your site that is very small, it's also a huge benefit to do this type of technology. A moving bed bioreactor is actually very similar to a sequencing batch reactor, except it couples the RBC treatment. So we talked about that film on the outside of that. So essentially, there's millions and millions of these plastic rings that then get mixed around in a tank like this and use that film to treat, again, the biological material. These 2 options are much more expensive than either the sequencing batch reactor or the RBCs. Our company has designed a number of these as well. There was actually a big story from the Connecticut River. There was a plant up in either Connecticut or New Hampshire using a moving bed bioreactor. There's no good way to hold these in the tank sometimes, so it overflowed, and there was like millions of these things in Long Island Sound. So it's still a good technology. They're a little bit more expensive. It's not quite right for this size facility. Oxidation ditch, again, uses microorganisms to break it down. They're circular tanks. It has, similar to the SBR, mixes using air, settles. It does everything essentially in one tank. They don't have the ability really to handle peak flows. So that was kind of off the table because obviously we know that there's peak flow issues here, and so the real selection was sequencing batch reactors. It's equivalent cost-wise to the rotating bioelectric contactors. The other benefit of the sequencing batch reactors is it gets better treatment from a speedies permit standpoint than the RBCs. And additionally, we know, based on discussions with DEC, that regulations are changing. They always change. It's been since 1970, there's always getting more stringent regulations. The sequencing batch reactor has the ability to change cycles and treat wastewater better. So nitrogen and phosphorus are the 2 biggest things that is talked about in New York State right now. You've probably all heard of harmful algal blooms in lakes. That's nitrogen and phosphorus. And so you see across the state that the speedies permits are being modified for lowering nitrogen and phosphorus significantly. And sequencing batch reactors, again, going through their cycles, can treat that. So when you have a permit change 5 years from now, okay, now we run our cycle 30 minutes in this way and 40 minutes in this way, and we can treat that nitrogen down the road. You can't do that with rotating bioelectric contact, unfortunately. So.
Can you just give an idea of the difference in the cost between the one you're suggesting and the one next to it, the membrane? I'm just curious. You said it's less expensive. So what do these things cost?
Well, we have a whole slide on that.
Okay. Okay.
I can give, I mean, in round numbers, and this is not, this plant, but if a sequencing batch reactor.
Not speaking to the numbers that we're going to talk about.
No,
today.
I'm just saying, if a sequencing batch reactor is $1 million, an RBC was 1.1 or 1.2. They're relatively similar in total cost. But you have ease of operation, better treatment down the road, and it treats obviously better peak flow. So RBCs also have a peak flow issue. And so the reason they're actually cheaper typically per unit, but you need a lot more units of these.
But I was comparing it to the one that you said was expensive.
Oh, these?
Yeah.
Oh, so if this is $1 million, these are 3.
Okay, that's what I
Yeah,
wanted.
yeah, yeah.
Okay.
So,
I would also add, Jeff, I mean, the MBR that's here is also a lot of energy. It's a very intensive treatment system. So there's also operating costs that go into the consideration of what we're looking at. And when we look at the nexus point of all the different things that Kevin has described, the SBR at this point appears to be giving us the best value treatment and also considerations for storm events that affect the treatment. So it gives us the best treatment. And
membranes are also difficult to operate to some extent. They need much more,
Higher maintenance.
yes. I mean, there's, if something goes wrong, somebody needs to be there, whereas SBR is literally a timer saying, we're gonna settle for 40 minutes, and then we're gonna mix for 40 minutes, and then we're gonna settle for 40 minutes, and so it's a much easier operation. Yeah, I get it.
I was just gonna ask, maintenance-wise, what are we looking at? Like, I know you said, I mean, do they have to be looked at every year? Should we, you know, are those costs incorporated into the whole project?
So we've developed an operating budget for the facility to operate the current facility, and it is very similar to what we need to do with the proposed facility. There are certain changes, there are escalations that are occurring now that are unprecedented, and we will need to add additional funds to the treatment plant for the operating costs of whatever we do here. But we are building that into our budget this year so that we can complete the construction that will be phased through this process, continue operating the plant, meeting our speedies permit hopefully during that period. And there'll be additional funds that are added to address that and make sure that we have a fully funded operating system. But I believe we are on the right path, and I will speak to that in some comments. I'm not going to give the operating budget tonight, but I'll show the costs.
That's the question.
Yep, go ahead.
So you said that this sequencing batch reactor has the ability to change cycles.
Yep.
How does the RBC and oxidation ditch do that if you had to? You don't?
No, they can't. So,
Can't.
no, RBCs cannot change cycles. They literally just spin, go into the water, go out of the water. They use that film on the thing, that's all they do. What's that?
Single pass.
Single pass, right. Oxidation is the same thing. I mean, oxidation that you have a little more control over changing cycles, you can do that because as you go around in the circle, they can mix using oxygen and then not mix using oxygen, but they don't handle peak flow at all. It's very difficult to handle peak flow.
You know, it's a little bit like electric windows, you know, on cars. Sometimes you go, yeah, it's broken. So that's my question. How new or how useful is this technology? You're aiming for the middle one. The older ones are obviously sound older, you know. So is there a, how long have the SBR been used?
So the process of SBR, so it uses microorganisms, it's mixed with air, and use those to eat the food essentially, has been used. It's called, technically it's an activated sludge process. And that process has been around for 100 years and been used at treatment plants all over, and still new plants are designed that. An SBR particularly is for small footprint areas to treat using the same process. But the process itself, as far as it uses air to activate the bugs to eat the food, has been used for 100 years.
If I may speak from the operator's perspective,
Yep.
I'm not an operator, but I work closely with them. When we look at the different technologies that are here, they all require maintenance to be maintained through time. When we look at the sequence batch reactor, it uses very simple technologies that are accessible to the operator to manage. There is a air system that sends air into the system and allows the biology to do its thing. The blowers are atop. They are a standard technology that's been around for a very long time. We are experienced with them, and there's no issue with that. There's a decanter bar that moves up and down with the water to send the water out. It is an innovative design in the way it operates, but it is accessible to the operator without reaching their hands into the material. And so the operators have looked at it, they've operated these before, and we find it to be a very good technology that is accessible, robust, and capable. All the other components upstream and downstream that we will talk about, the operators have looked at, and again, we have used them elsewhere, and we find them to be capable, robust, and good technologies to use. So we are confident in this technology.
And all of these things are dependent on electricity, I assume?
Yes.
And what kind of a backup situation is there for that?
The current wastewater treatment plant and lift station that send the sewage down to the collection system do not have generators. In the past, the facilities were built without them. We propose to include generators that are able to run the facilities in full. So if there is a power outage, if you remember back in 2004, 2006, there was the Northeast blackout, right? We were all there. We will have generators and able to run this facility and continue to treat the materials.
That's a good idea.
It's, I believe it's required under Tennessee standards.
Have some means, whether you have a generator or a plug to bring a temporary generator in, yeah, it's required.
If you don't have a generator on site, the problem is everybody probably needs a generator on the same day.
Right.
And if you have shared services agreements or partnerships or contracts to have those generators delivered, you might not actually get the physical generator delivered. So having the generator on site is important to making sure that this is a good technology and works well. If you don't have a generator, can't run it, it's going to, with any facility, it's going to run onto the ground, so, which would be a spill. So necessary component and will be included.
And just to finish your question there, the two oldest treatment methods are the RBCs, which is called a fixed film, so that film that I talked about, and activated sludge in this. So in oxidation, that chooses the activated sludge method as well. This uses both activated. They're all really the same, doing the same thing, with slight intricacies that are a little different. So the moving bed bioreactor uses both activated sludge and fixed film. So they're all variations of the same process that have been used for 100 years. Just
But
different.
the SBR is a common technology, and the materials are available for repairs and upgrading, and
Absolutely.
it will have a good, useful life.
We went and looked at least, well, two of them, because we looked at both different times of SBRs that are within an hour of here, but multiple of them. There's many of them in New York State alone, let alone in the country, so.
And the operators currently operating the Tivoli system, Cody and Vanessa, are familiar with this technology and have operated.
I have a question.
Yep.
The new wastewater treatment plant, what is life expectancy?
It's typically 25 to 30
It
years.
still is, so
Yeah,
no
yeah.
matter what.
The
we
tankage itself will last much, from a concrete standpoint, will last
Like-
much longer than
do.
that.
Okay, so
But like
structurally.
the
structures,
decanter?
I should say.
Yeah, the decanter probably gonna be replaced in 25 years. Same with the blowers, stuff like that needs to be replaced. The tanks will last.
Equipment,
He's not that
actual-
Many of the
Okay.
Many of the components will be stainless steel that are used to convey and move the liquids. But keep in mind that we are trying to use technologies that will have concrete tanks that are a legacy that will carry forward and are durable, very durable. Everyone uses concrete. The components that go around this are items that can be repaired by the operator. The blower breaks, the blower has an issue, we do our own maintenance, we're able to repair that, we're able to get a new one on site. The blower goes to a manifold under the water, which then aerates the water. And this, again, is something that we might need to bring in a contractor for because it's a larger job, but these are all things that are doable. And so when you look at the different technologies that are here, we go to the RDC that we have now. Very large shaft, lots of media, very expensive to do repairs on that. You have to bring in special contractors if you can find one that will work on a government site. And they're very expensive to maintain when they finally do fail. When we look at the membrane bioreactor, the MBR, it uses cassettes that need to be replaced periodically, and they are very expensive, and you need to have different housings for them. It's all automated. There is no way to really run that manually. The sequence batch reactor is, yes, automated, but it is possible to run it in a manual mode. Someone will have to be there when they do that, but we can flip switches and run it manually. The moving bed reactor is somewhat similar. It's again just blowers and then the media that you hope doesn't get flushed out because you have a huge storm event, which it is currently dealing with. And then the oxidation dish is more simple technology. But when we look at these, the SBR gives us a robust technology that the operators are able to maintain themselves. And when we look at the long term, the components that are on the outside, we can maintain, we can replace them over time. So it is a good technology that is accessible.
And it's the least expensive.
Yes.
I think, if I may, just being mindful of the time, because we're coming up on an hour and a half almost. It's 7:45. So if we can get through the presentation, I mean, the conversation and the questions were fabulous, but maybe we'll get through it.
Yep.
It's just so people can get everything, and then they can stick around and do more Q&A.
We love to talk about wastewater, so
Yeah.
anytime you want to talk about the coolers, the sludge, happy to do that. Continuing, so sorry.
So tertiary filtration, we talked about, guys have sand filters now. This is a disc filter, so instead of being filled with sand, it goes through these discs. They capture any of the other solids. Those are backwashed, and those go to a sludge holding tank. So essentially just removing smaller, smaller, and smaller as you go down the line. So we have disinfection, again, back into the plant. So chlorine is used now. Again, I mentioned it earlier, the issue with chlorine is you have to add another chemical to remove chlorine because the DEC doesn't allow you to discharge chlorine into the river. It's a chemical, it's just not ideal to use. UV or ultraviolet light, most plants are going to them now. It doesn't require chemicals. It essentially inactivates any pathogens or viruses by using the light. They're clean, they have bars go across and be clean, or they can be pulled out, and they're essentially quartz lights that are 6 feet long, and they're cleaned manually or automatically, in this case manually. And again, going back to my point, these will be sized to treat 1 million gallons a day. You have to disinfect no matter what. Anything you do before it goes to the stream has to be disinfected. So these are sized to get to 1 million gallons a day. And then post-aeration, again, talk about dissolved oxygen, has to make sure the fish and the plants have oxygen. So see the grid at the bottom, essentially just aerates, provides water, or provides oxygen into the water. This is actually a sludge tank that we've designed, but it does the same exact process. It's air into the water. So this is the replacement of the pump station that you have now. So there's some photos. It's a very
So right across from St. Sylvia's, that little brick building with green door at the end of the driveway, that's our pump station. And that pushes sewage from the acres and the gardens towards the plant.
Oh, I
Right.
never knew that.
So that one is a building, and it sits on top of essentially a tank like this. Again, the pumps are down there similar. This is a prefabricated structure, much easier to install. So what will end up happening is this is installed while the existing one's operating, and then you just switch it over. The other benefit about this one is that little brick building is vandalized a lot. There's windows in it that are broken, etc. Everything's below grade, so there's very limited ability for anybody to really vandalize it because it is in an open
The
space.
vandals know what's in there.
If you told them, they may not want to.
This new facility will also incorporate certain protections, so if someone were to find a way to get the right key and open the unit, it has ways of protecting people from falling into the very deep shaft.
Right, that's what this red, it's like grating that goes over it, so when the operator opens it, it can't just fall in. It's a catch, to get that stuff. So it's sized essentially the same. Your existing station does handle the flows that it needs to handle. This will be sized very similarly, but it's all below grade. You'll see it, and it's very easy to construct. So that's the pump station that we replaced.
And will this have a generator too?
This will have a generator as well, yeah. So somebody asked about, hey, can we reuse anything? The answer is yes, it's limited, but there are things. So if you remember, there was the control building that was kind of sitting here, and then there was a circular concrete tank. That's called an Imhoff cone. It was actually probably one of the oldest treatment technologies. It's a cone that does a bunch of different, it's kind of like the SBR actually, it does multiple things in the same tank. It's not currently used, and so that is going to be converted to a sludge holding tank. And so, and the reason for that is it's up near the road, so when somebody comes to pump off the sludge, they don't have to kind of drive all the way down the back. They can pull up right next to the control building, pump off the sludge, and go on their way. There's very minimal improvements really. It's because it's a cone, we have to fill in the bottom of the cone to make it more of a square, and then we're putting in some aeration in that just to mix it as we need to. The post aeration tank also, again, while we're going to concrete, the concrete's great there. We're just gonna resurface it and then put in a grid at the bottom for air again for post aeration. So reutilizing that tank, and then the control building. The general bones of the building are pretty good. It's just a matter of upgrading some things inside, bringing it to code, and adding a few, part we didn't really talk about yet is everything powered here is actually off of 220 volt power for a wastewater plant. That's not good. So 220 is your dishwasher, your stoves, things of that nature. Pumps, blowers typically need something with much more voltage, and so we are changing to 480 volt, which is more typical of a wastewater plant. It actually saves electricity use, even though it uses more voltage, it uses way less amps. So from an energy efficiency standpoint, it's going to be much better for you. We'll actually talk about that from a funding perspective here in a second. And there's very minimal cost for that because 480 volt power is actually already at the plant, just not distributed through the plant. So some of those upgrades will be added to the control building, and I guess where I was going with that in the basement of that. So we are utilizing as much as we really can from existing features.
So this is the slide you've been waiting for.
There we go.
So every good presentation comes to this point. So what we've tried to do here, I'm just going to give you a general overview, and then I'm going to walk you through the numbers. So essentially, we are at a certain point in the project where we've hit 60% for our design for the wastewater treatment plant replacement. That includes the pump station. We're also pushing at the same time the collection system improvement. We're just here to talk about the wastewater treatment plant. The collection system is included in this number. We have a tentative number right now for our total project cost. We have grants that are applied through, whether they come through Dutchess County or through the Environmental Facilities Corporation in New York State. We have an amount that is the total cost to be financed. We have a borrowing term. We have an annual debt service. We have a typical single-family cost. Single-family would be a dwelling, a house, an apartment. Basically one kitchen, one family. We then break the cost out per the capital cost. So this is when we build something that is large, say a wastewater treatment plant, sort of like building a house. You get a mortgage, we get a bond, and so there's an annual debt service that goes with that. So like a mortgage payment, we pay it once a year, and we apportion that out to all the property owners in the district through a methodology so that everyone pays their fair share based on the benefit they derive. And we show the cost for water and sewer here. And then we have the annual operating costs. So this is sort of like you have a car, you've got to drive it, and you've got gas you got to put in, you've got oil you got to change. That's your cost to make that car go. And we again are showing the water and the sewer. We show it then as a total for the household cost, total for water, then for sewer, or for sewer, then for water. And then we total it here at the bottom for going forward based on current numbers, what we're projecting. We have provisos on the side, which basically just fill you in at different points to help you understand this. We're going to talk a little bit more about this, but we have this total cost that we're going to need to finance after we take out the grants off the top. And the project partners, the village, the water authority, like Pierce, are working to find other funding sources. And we'll go into a bit more detail about that on the next slide. Two, we have a term with which the borrowing can be bonded or a mortgage. Typically, there's a credit card or short-term financing that's done for about 2 years while you're doing construction, and you add that to your long-term borrowing, which is 28 years. You get 2 plus 28, which is 30 years. Annual debt service at this point, we're based on hardship financing through the New York State Environmental Facilities Corporation. I believe this is going to be posted online, so we get a really nice. Joel, you're going to put this up?
We are going to put the whole slideshow, and I forgot earlier to thank Panda for being here for filming tonight's presentation.
About that.
Yes.
Oh, good.
So for all those other people who didn't come tonight,
Yeah.
but they don't get to pose their questions like you all do. So yes, all this will be available going forward.
Just save you the photo on your phone. So, and so annual debt service. We have with the sewer system, the community based on its financing package will look at grant State Environmental Facilities Corporation has hardship financing for a portion of the project at this point. We're looking to have that extended to the entire project because of the changing costs that we're seeing in the area. Then the last two provisos are more about the water, and they speak to this number here for the capital cost of the improvements we did for the tower, the pipes in the ground, the well improvements, the well building. Those we project right now, we're cautiously optimistic that that number that you saw in your tax bill this year will stay relatively stable next year. But we haven't finished the work yet, so there's potential to change. And then finally, there's the operating cost, which is based on 100 electric hours per day for a typical single-family home with just one dwelling and one kitchen. And so we're giving you the overview, kind of walked you through it.
So, quick question?
Sure.
So that total annual water and sewer cost is an estimate based on what we're gonna see in our tax bill and what we see in our water bill we get from you? right?
Yes. So this annual capital cost that we have listed here, where you've all seen your tax bill at this point, and there's the $282.
Yes.
That is your share of the towers, the pipe in the ground, and the improvements to the well site.
And is that an annual cost, or
It
is that
is
just
for the life
this
of the
year's?
borrowing. Annual.
So
Yeah,
I
so-
called, just FYI, so you know, I called Red Hook for town to ask
Yes.
that question, and they told me it was just this year. So just so you,
I've spoken with the town
Yes.
clerk because people from Tivoli, this was showing up on their town tax bill.
yeah,
And they weren't reading Tivoli Zone 10, it's all new, blah, blah, blah.
no,
So
I knew what it
Yeah,
was.
so she was getting calls, so I've told them, but I've also said, call the authority because they can explain that to you.
Okay.
Yep,
She
and when you
literally
call the
said to me,
authority,
it's
you'll get
just
me and I'll walk you
it's
through.
1 year. So
Yeah,
it's
she
every
had no idea what it was, so
Yeah.
that's not her fault.
So it's every year.
It is for the life of the borrowing. And keep in mind that it's due because we're doing a major improvement over the life of the project. I'll get to you. You're looking 30 years down the road, there'll probably be another improvement at that point. So whoever's here at that time will share the cost of that. But for today, this is where we are. Sir, yes.
At the very beginning, there was a question of like 60% for the water and 20% for the sewer, if I understood now.
Right.
But this number is actually an old number, grant. It's not based on the cost then, or
So
it's not currently 20%.
So,
Is there any
so those
chance of-
percentages that I was, so
Yeah,
I guess the water system, because we're further along on that process. So the water total system, we've figured out how this is going to be 4 million something, right? And we go to the state EFC and say, this is how much our project is, please give us a financing package. And their rules are, we'll finance 60% of your project. So that was the 2.8 million we got for the water.
Yeah.
And then the remainder, that is then into the 30-year borrowing. And the 281 that has shown up on everyone's
That's clear.
property assessment, that's us paying back the loan. So that's like paying your mortgage.
But my
It's a steady
question is-
price.
My question is, at that time, there was a 20%.
Right, so that,
The 919 was based on,
yes, it was
what,
based on,
5
it
million.
was based
So
on.
now we've got a top line of about
Yeah,
12 or
and
13.
Jonathan, could you just read the numbers?
Yeah, I will.
Yeah, okay.
So the old project numbers are many years old. And so we've seen escalation both just in CPI, Consumer Price Index. We've seen more recently that inflation is affecting projects. And the nature of what we need to do here at the wastewater treatment plant, the liabilities that were the parcel are causing escalation. And so the current project cost has actually changed from when it was originally proposed to EFC when you got the grant that was listed here. And so we are going back to EFC to ask for what they can do. And in the next slide, we'll talk, I think it's the next slide, we'll talk a little bit about the other funding agencies that we're reaching out to, the other ways we're trying to economize the project.
So you're saying that that bottom
So that
line,
919 was 20% of a much smaller project.
Exactly.
Yes.
Right.
so I was just, is there a new request going?
An additional grant.
Possibly,
Yeah.
different kinds of grants. And I would say that this total project cost that we're showing here is a 60% design. And so this
It's a what?
design, 60% design. So as you go through, you look at a project from the perspective of, we're just starting out. We have a concept, you put a lot of contingency on that. As you start to narrow down your design and get into 60%, 90%, you're at 100%, you're again narrowing those numbers down and trying to refine. At 60%, we're to, probably this is the number, unless the regulators throw additional requirements on us or there are different things found through the project. The next point in time where we will know the actual number that is here is when we put this project out to bid after it's approved by the regulators. Contractors will then tell us what they're expecting it's going to cost, and that will then refine this number, and we'll come back to you again and talk again where we are, and we'll give you new numbers. Part of what we're doing at this point is we are reaching out to the financing agencies to get more grants and also try to secure more hardship loan opportunity here, so you don't have to pay interest. And so this is our projection of $13.4 million for the plant and collection system. We have a Dutchess County grant, which we thank them for very much, $50,000 that will come off the top to help with installing generators in the project. There's a WIA grant, which comes from the New York State Environmental Services Corporation, and we're very thankful for our partners on that project, which is gauged on the original project cost of 20%, and it works out to $919.
I'm answering some questions on the side.
Okay.
So the total project cost, $13.4 million. What we have so far, we've got a $50,000 grant. The county was basically, we put in an application for generators. So the generators that are going to go with this, we've got $50,000 to cover the one at the pump station, right?
Correct.
And then that $919,000, that is our original 2018 grant award. Then, even back then, the remainder of your project cost is EFC zero interest funding. That's the hardship funding. So we've got that locked for the smaller version of this from years ago. And we need to go, that's one of your star points to the right, we need to go back to them and say, the project now costs this, extend our zero interest financing further.
We did submit, we submitted on time, and we spoke with.
So that request is in already.
Already went in on the 17th.
So that leaves us at 12 million for?
Yep, when we deduct out all the grants that we've secured so far, we're at 12.4 million and change, and then we do the math and we end up at these numbers here in the middle, but the key one is that we combine both the water and the sewer for the way we would charge the capital cost and also the operating cost multiple times per year you get a regular bill. All those dollars added up into a single total for each year, $2,156 for water and sewer.
Per household.
Per dwelling. Right.
But we're basically already paying the operating cost, isn't that correct?
Yes.
Through our 156 or whatever it is that we pay every 3 months.
Yep.
Okay, so the new expense at this point is really just, not just, but is the capital cost.
Is the capital cost, the infrastructure that's needed, and to go forward. And the sewer plant operating costs may change some because we will have changes in operation. The new plant will require sludge to be hauled off-site, and so that will come with a little bit more cost. But we are factoring that into the budget now for the operating plant, and we will, I believe, be on the right track for next year to include that also within CPI.
Question. So the bills that we get now every 2 or 3 months, will they change to monthly?
No, they'll remain on the
Still
same
remain.
cycle that you have.
Oh, okay.
Yeah.
And then, I'm sorry, I apologize if this is a dumb question, but, so the generators, are they run by propane? Or, what's gonna run the actual generator?
Diesel is preferred
Diesel?
because it is locally available.
And this is all incorporated in these costs?
Diesel is preferred because we're able to get it ourselves. We have mutual aid agreements with other entities, and so the county has tanks at a central location, and we can hire a truck and they can go bring it to us, and we've done that before. Propane is much harder to do that.
But your regular electricity, which is going from 220 to 480, I understand that there's a differing cost for the supply and the delivery. We can't change that Central Hudson is going to deliver it. But who do you have currently supplying the electricity, and are you considering different options in the future? I have sustainable wind and solar source energy, and my bills are cheaper than my neighbors.
Currently, the facility is served through Central Hudson, and so we are buying our electric from Central Hudson.
You would not consider that?
We will consider other sources, and we have done it in other communities where it made sense. So if there are opportunities, we'll look at them. It does sometimes add cost, and you have to be mindful of how it fits with what you're looking to do, because this is a larger plant, and that's probably beyond tonight's conversation, but I would say we would consider it. So there are opportunities sometimes to do that.
Thank you.
You're welcome.
I have a question. So 13.4, it has plant and collection. Is that something that could be split? Like say, I don't know, for whatever reason, you could only do the plant and not the collection? Or does it have to go hand in hand? One can't happen without the other?
We have to do both.
Okay.
And right now, the collection system number has shrunk. So more money has gone to the wastewater treatment plant over time with the evaluations we've done. If there was money left over from the plant, we may be able to use that on the collection system. We need to do a bit more evaluation to define the nature of the improvements that are needed to the collection system, so we know what the number is. But collection systems are funny, and again, I'm not going to get into too far into it, come back another day. But the collection systems are something you're always working at, trying to address that inflow and infiltration, and you're taking multiple steps there, and you're never really going to resolve it. And so, unless you're going to replace all of your collection system, this system has a considerable amount of old clay pipe. And if we can do that lining that I was describing, it would be the most cost-effective method and hopefully get us to where we need to be.
And that would happen first?
Hmm?
That would happen first, or kind of?
We're doing them in tandem.
Okay.
We're doing them in tandem. So the goal here is that by the time we're done with this wastewater treatment plant collection system, we'll also have whatever improvements we can do. And then we'll be able to then monitor to see how those have worked out. It's kind of a cat and mouse game, trying to find the inflow and infiltration, address it, and waiting and watching for where it's coming from again. The system is always changing, and especially with an older system like this. Sorry. Actually, this gentleman was... Hi.
Speaking of sequencing, you're reusing some facilities but changing them considerably. Are you able to do this project without any interruption in the
The plant will continue to operate through construction, and we will do our best to meet permit. Kevin, I think, is going to speak to how we're going to do the replacement of the facility to optimize that scenario.
Yep. So there's going to be really two phases for the project to make sure we get this done. So the first part of the project is going to replace the front end of the plant. So we talked about the headworks. Headworks is the string and the grit system, and then also the SBRs. And so we're going to utilize all of this space in here. So there is the drawing back over there. You can take a look at it afterwards. But essentially, the two SBR tanks are going to go here and install those. The headworks, so the screening and the grit is going to come up here. So all that's going to get installed, operational. And then we can take out the headworks here, the grit here, primary clarification, RBCs, secondary clarifiers. All that can go once we get this stuff installed here. Once that's done, then we come to this all gets demolished. We put a new building here, similar to that one I showed you, where the filters and the UV are going to go. So that gets installed. And then we can remove filters, chlorine, which is actually in secondary clarifiers, and all of this section goes, as well as, at that point, all of this. Actually, this tank is going to be done probably first because it's for sludge hauling. So right now, sludge is here. That'll be immediately moved to here. So that'll be first. And so it's really a two-phase approach to that. The only thing that's going to be slightly different is that post-aeration tank. That's going to be probably the trickiest part of it because we're keeping the tank, right? And so what we'll probably end up doing is doing some bypass pumping. So we'll pump around it, make sure that we're still meeting the oxygen limits while we do the minor upgrades to this, and then we'll take that pumping, temporary bypass pumping off and pump back and go back through that tank. But we do have this room here because we're getting rid of the reed beds as part of the project. Yep.
So I have a question. I have to go and I hope to meet again. But, so, the costs. Are any of these costs reflective of what it's gonna take to, because again, the 1 million tank water flow. Are any of these costs reflective of what it's gonna entail to fix the pipes in the surrounding areas? So
Yes.
also,
That's included in the project. So if we're going to do the collection system, we're going to do the wastewater treatment plant, the amount of money that's required to do the entire collection system is probably not included in this number, but I believe that there's a lot of value. When you do a collection system job, you're looking for where are your biggest leaks. You go through and you're looking for them. You're doing flow analysis. You're pushing smoke through the system. You're doing all these different steps, and you're trying to find where the big leakers are. You address those first, and if you've met your number and you've addressed it, then you're in a good place. You
And
may not
this
need to go further.
includes those preliminary leaks.
Yep, and then the other thing to keep in mind is that we have a lot of legacy pipe here that's that clay, that 8 and 10 inch, and it needs to be either replaced, or if we can line it, we might be able to, the clay pipe ends up just, being the outside edge, and the new fiberglass pipe that's there is a new pipe that'll go for 60, 80, 100 years. So, again, I'm gonna come back another night, there's way too much detail there to go into. But yes, to answer your question, collection system is included in here at some level, and we hope to do a considerable amount of good.
When you return, can we bring our,
Assistant side doesn't usually get 2x4. I'll bring a piece of the half pipe that I can bring.
Can
Clean.
we talk about individual areas that you may have or may not have already looked at? And
We're gonna look at the whole system, and
so
we're
that
gonna do,
means all the surrounding areas, like all the homes in the condos or the homes in other areas?
the existing collection system will be evaluated for the purposes of where are the major leaks and how can we address them most efficiently.
Within that area? Not
Within the collection system.
the whole village?
Is that evaluation scheduled at this point, or?
Yep, contracted with Cybond Engineering.
Okay.
They've assisted in the past with components, and Lori is the engineer that'll be working on it, and we're finalizing the documents and we can get it started, so you'll start to see activity in the spring and the summer.
So we'll be seeing these people walking
Yep,
around and we'll be able to talk to them?
Again, we have to stick to the words. I'll be posting on the website, and I'll come back to talk about that more. I'm happy to do that.
Okay,
Take my card, call me.
okay, great, thank you.
John, can I just have a moment for slide 16?
Yes, let's go back.
I just want to state this in sort of a blunt way so we really get it in case you haven't. I want to be overkill redundant here because this is really the gist. This is really the gist of what I as mayor and the board want everyone who uses this system to get. And I have to say how disappointed I am in the people who aren't here tonight. It's hard, so I'm so grateful to you for coming. We've got a $13.4 million project. We've got about $1 million in grants, so that puts us at 12.4. If we don't find more money, which I'm going to spend as much time as possible going to find, if we don't find any more money, at the 60% snapshot, in the same way that that $281 assessment for our water has shown up on your tax bill, whenever it is in 2 years or so, that number that shows up next to 281 is going to be 1,090. Okay, that's just what I want everyone to understand. Now, if we can go out and get more funding, that number starts going down. But, I just want everyone to not walk out of here not understanding.
So you're saying, based on 60%, this is the worst case scenario
Yes.
projection? And if we
Yes.
find more money, then the cost on your bill will go down?
Yes.
And just to follow up, if you take $1,000 and you're talking about, let's just say 30 years, it says 28 years. So let's just say every household is going to end up paying $30,000 if they're here
Over
for
30
that
years.
time. How many people are paying? How many dwellings are there?
So there's 404 parcels that are in the sewer district.
Okay, so just do 400 times 30,000.
And that's not all dwellings. There's a mix of different uses. You've got commercial,
So
institutional.
that is 12 million, isn't it?
They're charged different, so
If you
it's
charge quickly, yeah.
commercial is charged different.
Okay.
So that's where that
So some-
$1,000
That's what
number
I-
comes from. You're
that's what
taking
I
the
wanted.
project cost,
This is dwelling.
dividing it across the
And I have one terrible question that you're going to hate.
Well,
What percentage of that goes to the Dutchess County wastewater authority and the consultants? What percentage of the total project cost? I've done this stuff sort of not-for-profit wise for years, so.
So this includes, right now, a design contract, which is $680,000 for the wastewater treatment plant. The collection system, I believe, is more on the order of 35,000, because it's a different kind of
That's not good.
effort. There are other contractors that need to be involved.
Would you
There's-
say $1 million?
Huh?
Would you say that?
Where does the,
I mean, that's about 10%,
Sure, it's not
but I'm just curious.
there's one more contractor that needs to be involved in both the collection system and the wastewater treatment plant, and that is when we actually hire a contractor to do work, someone has to watch them and make sure that they're following the specification, they're installing it correctly. And so there's another engineer that would come in and do that task also, and I think it's equivalent to what we would ask Ray Pierce to do. They may also be the engineer, we haven't selected that engineer.
So it looks like it's around 10%?
Usually about the numbers.
Okay. I think that's the
You've been waiting a while.
This might be more of a question for Joel, but I think it's kind of related with the collection system and the stormwater project.
Right.
How is it
They're
one
related.
helping the other, and what's that, we still haven't got information about that, so like the cost of that,
Yeah.
the cost of this, and then you're saying this is even gonna go up more.
No, they're hoping it goes down.
No, over the years, that's gonna go up.
Oh.
So,
We're hoping the capital costs here are fixed, but we won't know until we get to construct this.
Right.
And there's bidding, and there's
Right.
90%,
Right.
100%.
Yeah.
Right? So this is our best estimate at this point, and these are all tentative numbers, but we have a high level of confidence.
Let me
Yeah.
just take a
Yeah,
minute
'cause
to,
I'm
so,
freaking out.
stormwater, and this goes to Phyllis's question. My understanding, and I know of at least one personally, like over the decades since that conversation, the village has been separating stormwater systems from the wastewater system, as should be done. I know, one day there was no catch basin at the end of Washburn Avenue, for example, because that used to go into the sewer system, and then it was gone, which is a good thing. You don't want to treat stormwater, it's different than the stuff in your toilet. It's expensive to do and a waste of resources. So, as I think most people know, the village, at the same time we're doing this and chasing the firehouse and everything else we do, we are in this drainage and stormwater study, because there's all these cracked old clay pipes, there's inflow and infiltration, there's also sump pumps throughout our clay village with flooding basements, and we know that some of that stuff is going into the collection system for the wastewater treatment plant. It shouldn't be going there. And that's going to be another piece of what we as a community with the Water Authority are going to be working on, is figuring out where should those sump pumps go. If they can't go in the sewer plant, we have to figure out where else they're going to go. And so that's part of the stormwater project as well. But you're correct. I mean, we're in phase 2 of that, which is really just measuring the volumes of water. But at some point, there are going to be some concrete projects, like this area needs like a new storm drain and a pipe. They never had it before. And we're going to have to figure out how to pay for that as well. And some of those funding sources for that kind of work are like CHIPS, which we were able to get. We've got a great track record of that, and CDBGs. But yes, we've got a lot more going on than just the sewer plant.
I just want to thank the mayor and the board of trustees for the tremendous amount of work that they've put into this project. It's not a reflection of how they.
I just got a question going back to sort of the design and upgrade stuff. I live right across the stream from the plant, so I'm intimately familiar with the noises and the light and the sort of cycle of the year.
The breezes?
The breezes, yes, the spring breeze. There's always a spring breeze. But so could you just speak to what you would anticipate the new equipment being like in compared to what's going on now?
So just to give an example of existing conditions, these are in many cases failed or about to imminently failing blowers that have poor sound attenuation, metal enclosures, and then Kevin can speak to the new technology.
Yeah, any of the new blowers, so we talked about blowers for the SBRs, the aerated grip, post aeration, those all come with enclosures on them with sound proofing, essentially not 100%, but it brings the decibel level down significantly, so you shouldn't hear, I mean, I don't know how far you are away, so,
So
there
what
may
you're
be,
used to hearing is a dump truck running very loud right next to you, and you can't have a conversation, while the new technology, we would have this conversation without raising our voices.
right,
And that would be in an enclosed space that I've seen these, the Kaiser blowers, I'm sorry.
no, you're all good, so.
And how about lighting, nighttime lighting?
So there will be lighting, I mean, if something goes wrong, they need to have lights on there.
Motion detectors,
Right.
site lighting, downward facing bulbs,
Right.
and fixtures.
So some lighting that can go off?
Yes.
Yeah.
Have you spoken with the operator about the lights in the past? or- I've not heard of the lights, I've heard of the noise.
Yeah, I've spoken with them about the noise. Okay. There's like a few of us who live right there. Not recently.
You're on the other side of the creek.
Yeah.
Okay.
Yeah. So, but it would be nice to just build that in, or be conscientious about it. I think, especially in the winter, it's something that, lighting
Like, see, the trees aren't,
creeps through.
yeah, the trees aren't, no leaves, so, yeah.
Do we have a lot of slides up?
Oh, let's rock and roll.
I have one other, I just wish we could really run this thing with solar.
It's a lot of power to keep this facility running, and it may be possible to buy solar. I'm sure we'll consider that.
Would you? Yeah.
I will ask that question. It is, we obviously wouldn't put solar on the site, there's no space for that. But to buy a technology, to make sure that we are buying into a power source that is consistent and meets the price point, our first goal is to make sure we have the right budget. So if it adds cost, it's probably a non-starter because it's already an expensive facility to operate, but we would consider that.
Yeah,
We've done it elsewhere.
to Jonathan's point, I mean, from a village perspective, the wastewater plant is the single most largest electricity user in the entire, for any community, every single time. It's not a question, and it's 10 times, it's not even close. So when he says a lot of power, it's a lot of power. So, but we want to touch on funding, obviously. We just talked about the slide, what it's going to cost you. So we talked about the revolving loan fund, that's the $990,000 grant, and the zero interest financing, right? So that's what we have now secured. Currently, we're looking at additional sources. And so the first one is the additional SRF funding. That's okay, we submitted the revised cost to the same agency that you have funding for to get potentially more money through that. That's already been done. These other three are currently being done right now, and so Joel has a number of documents that we've prepared from a congressional standpoint. So there's congressional earmarks, which is essentially funding that the House, which is Pat Ryan, and then Congress, so Schumer and Gillibrand, have additional funds. And so the board and the mayor will set up meetings based on the documents that we provide to go and request additional funds similar to the firehouse that you guys are doing right now. So that's one mechanism for funding.
Yeah, we've begun those asking for a meeting. We've been in touch already with Congressman Ryan's people, so also Schumer, Gillibrand. So yeah, that's going to the politicians to get some money. Yes.
What, you may not know, but like, what is the average that they would, like, what are you looking that they're give, like?
I want them to give 13.4.
Yeah, just 13.4, go for more.
Well, no, I mean, I don't mean to be flip, it's just that it's it's horrifying, this
Yeah.
number, so.
Yeah.
It's a shitty number.
For a little place like that. I don't know, Tina, how much they give. I mean, obviously, we'd be competing with every other, thing in their districts. But, as I've been saying to lots of people, the village of Tivoli didn't put this in 1938. The federal government was like the prime mover. And here we are again, in the expectation that a tiny community with a, tax base like we have, and everything we're supposed to keep up with and need to keep up with.
Yeah, I mean.
So we have a very strong case. I've got letters saying, you're not meeting your permit, you're going to get fined, and I get to take those to these people and say, I'm trying to do my job, please help do your job. Bring the money down.
Well,
To
yeah,
to his point, exactly, consent order sounds bad in general, right? You're in a negotiation with the DEC. It is the single biggest helping hand you have in all of this, by far. And to his point, they're usually very easy to work with when you do this consent order to make sure you're not doing fines, because they know it's an issue for you guys you can't afford that, right? So that is the number one criteria on any of these things is not are you under consent, but are you missing permit, all this stuff. So it sounds bad, but it's a huge help from a funding perspective.
It shows need.
Right.
It's sort of a game and everything is scored. And there's a system where they give you points for, do you have a consent order? Do you have these violations? Where are you at in your stage? And showing that we already have some financing and we also have grants, it helps to get more grants. Sort of a honeypot.
One quick thing, Joe, just doing this project, village residents, I don't know exactly what everybody pays, but I know what I pay. The tax bill is basically gonna be over 100% more than what I'm paying now. For those taxes.
It's a big cost, yes,
It's like crazy.
yes.
And when you need to go to politicians, this is what you need to tell them. I mean, where do all the senior citizens around here that want a fixed income?
No question,
Where do they come up and get this money from?
right?
I mean, last time I looked, I don't have a money tree growing out in the backyard.
No.
You know, it's like,
So,
what goes
you
on
know,
here?
tonight and, you know, where we are is like, this is what we have to do, everyone.
And I can't
And we,
believe
you know, we gotta go find out how to pull this off because we need a new sewer plant.
What, I mean, there's no other alternative, right? Like, we're either gonna be paying $1,000 more on our tax bill, or we're gonna get the funding, like, there's.
Yeah.
So we've looked at another couple, we did a bunch of what we call value engineering. And so, because we know what this costs is. So a lot of times, in situations like this, we'll look at, especially for small communities, is there another community close by that we can just pump our stuff to, right? I'm telling you, this is what happens a lot of times. So small communities will just have a large pump station and pump to another place, right?
Right.
We don't have that here. It's miles and miles and miles away. The other option we looked at is Stony Creek, because of the size of Stony Creek, has much lower limits on stuff we talked about. So we looked at, hey, can we now pipe to the Hudson River instead? Again, it's too far away. It's a long way away. So we looked at many, many options that with similar sized communities, there's usually something else, but there's unfortunately not from a treatment standpoint.
And could you just speak, like, not to get into the costs again, but I know, like, that's just a big number for everyone, and I'm sure everyone's thinking, like, how did it go from 4 million to 13 million? So is there some way to, like, just pick that apart a little bit, understanding that we're in a new financial situation, there's inflation, there's all sorts of costs, but, like, how did that go from those?
Yeah,
those
Yeah, if I can maybe kick that off. Back when it was a $4 million project, the aspiration was still to repair and sort of, you know, Band-Aid and keep the old plant going. And in the subsequent years, particularly when the Water Authority came in and was really operating this thing, it became clear, and then our you know, threat of fines and exceedances, it became clear that, no, you can't even repair this thing, it's too far gone. So that's a big part of it, and then
the photos, look at the photos, you'll see that it's very, very, we use what we can. To your point though, so when we do a 30% design, because we talked about 60 right now, so we'll do 30, we'll do our estimate, we'll go through the process evaluation of what processes we think will be the best. Going from 30 to 60, we do field work. And so that includes survey if we need it, it includes wetlands delineation, it includes geotechnical boring, so we drill into the ground. One of the biggest issues here is the reed beds. The soils are really bad from a support standpoint. And so when we do a 30% design, we don't expect to have a 2-foot concrete pad under this huge thing, right? Because we don't know that. We're assuming that we have to make some assumptions at 30%. That was probably the biggest one, is that the soils are just bad on the site.
So you have to pour a lot more concrete.
A lot more concrete to support things. So that's probably the biggest number one that made it go up. It's the site conditions that we don't know at that stage of the project.
But at 60%, there should not be any big surprises like that.
Correct, we've done the field work, we know things, unless, like Jonathan said, the DEC comes in and says, no, you have to do this.
Right.
And that's out of our control, but we know the site now, because we've done the field work, so yes.
And
So
we
we're
are
looking at the
actively,
worst case scenario for money.
and we are actively working, we're actively working with the regulators to understand any permit changes that might occur with the implementation of Dynamo. And so we are having those conversations to understand that.
I don't expect to live that long, but when you say it's got a life, 25 to 30 years, what happens then? I mean, I do have a sense of responsibility for the people who come after us. So, there's obviously been, would you have to redo the whole thing again in 30 years, and what do you foresee there?
So no, I mean, the concrete, these are all steel tanks, right? There's no reuse whatsoever. Concrete's gonna last you, I mean, those tanks are put in 60
So they'll
years.
last.
They're gonna last a real long, so we're talking about, the concrete is a huge factor in this cost, right? So, once this is all in, now you're just replacing that decanter mechanism that removes the water, or you're replacing a pump. The structure itself stays, so it's.
In 30 years, you don't need an entirely new plant.
Exactly.
At that point, especially with good ongoing operation and
Yes.
maintenance over those 30 years, part of what happened to our village is, the last 30 years, things weren't getting done that needed to get done. And even, we did our best, but we're a little village, got part-time folks. And, that's how we got here. So hopefully going forward, I think even on the water system, this is one of the reasons that I think most folks in the community thought transferring to the water authority is the way to go, because that's all these people do. And Stacy left, but they're not a for-profit corporation. They're a public benefit corporation. They're not in this to make money. They're in this because the state created them to take on troubled water and sewer systems. And they will maintain it and operate it, I think, better than we were able to going forward. So hopefully in 30 years, we won't be having this meeting again.
I think that, to your point, many of the repairs we would do over time are easier to do because of the way this has been designed and oriented, and it will be something that is more in the operating budget. There will be improvements over time, but I think that 30-year plan is what we're looking at here, and we'll be able to maintain those little components over the top. A lot of legacy here for the future. The next generation will thank you.
And climate change considerations?
Yep, so the new, we're designing a plant now, particularly for raising of river levels, et cetera. So anything in the plant, so we look at the high water level, even for Stone Creek. And then the new regulations for the state is actually adding 3 feet to that, and so we make sure the plant is operational during all those times. So that's all we've done, yeah.
And when you look at the grading plans, most of the components are out.
Yeah, we're up. Just before we end, I guess, I have cards over there, if anybody has any questions, technically, they say, hey, I didn't understand this, they're over on that table, so feel free to shoot me an email.
They also have cards, so if you have questions of the collection system, I'll be back.
Also, Jonathan brought a clipboard back there. This is to get robocall updates and alerts from the water authority, so if you want those, please sign that.
There's a sheet where you can sign up to put your phone number down, your address, your name, or if you just want more information about what it is we do, there's a sheet there where you can learn about our robocalling and our alerts and advisory system, so you can take that sheet and then call us, email us, use the website.
So, we're going to kind of break up now and, definitely study these images, those plans. These gentlemen will be here to answer further questions. I'll be probably the last one on the building, so if you have other questions about some of this, I'm here. Thank you very much for being here. We're going to move forward. We're going to find some money.
Great.
We can do this. You guys both and Gary for all the work that went into everything, not just tonight's presentation, but helping us get a new sewer plant. So thank you very much.
Some
So that's there now, there's a transformer. Power. Probably not gonna have this here, it's replaced with transformers, but it's gonna be somewhere. It has to be close to the road, that's the central, that's the access, but it's more likely to be inside the fence.
Up to 45. So it's a decent size, yeah, decent size facility. I'm curious to see what happens with the one in Chicago. So close. No, because they haven't agreed to pay us. They haven't filled out they haven't signed the contract.
That's the other structure that we're planning to use. Come on, for like 30 seconds. It has flooded, because it's flooded over 80 years. Somebody a while ago, they're building a box.